Hi and Assalamualaikum. My name is AHMAD SHAKIL bin ABDUL SHUKOR. In this video, I will discuss about what I have learned and understand from lab exercise 03, analyzing spatial data in ArcGis software of LAS 618. Let's roll. To introduce into this lab exercise, firstly we go through chapter 9, which is spatial analysis. This chapter teach me to apply several GIS tools for spatial analysis, such as buffer, spatial joins, intersections of map layers, and cluster analysis. This chapter consists 3 main tutorials. For tutorial 9.1, what I have learned about buffering points from proximity analysis. This tutorial make me understanding about creating a buffer, intersect buffer, and drop cells. Next one, for tutorial 9.2, is about conducting a site suitability analysis. This tutorial taught me to identify which potential area and locate it on map documents. This tutorial also consists of steps to define buffer car bit centroids, buffer bit car centroids, and intersect buffer. Last one, for tutorial 9.3, is about using multiple range buffers for calibrating gravity models. This tutorial about analyzing the intentions of used data. This tutorial contains steps of creating multiple range buffers to open pool, spatial join buffer, pool tags, and use population, compute use rate, and create scatter plot of use rate versus average radius for each buffer's range. Next, into interesting chapter 13, which is terrain mapping and analysis. In this chapter, I learned how to analyze the terrain mapping and using a DEM and TIN. This chapter, I have to complete 3 main tasks, which are task 1, using DEM for terrain mapping, task 2, derive slope, aspect, and curvature from DEM, and task 3, build and display a TIN. For the summarize in task 1 is about using DEM for terrain mapping. In task 1, I learned how to create a contour line, a vertical profile, a shaded relief layer, and 3D perspective view from DEM. After that, in task 2 is about derive slope, aspect, and curvature from DEM. In task 2 is about how to derive a slope layer, aspect layer, and a surface curvature layer from DEM data. Lastly, for task 3 is about build and display a tint. In task 3, I do learn how to build and modify a tint by using spatial analysis, 3D analysis, and Alt Toolbox to perform mapping and analyze in this section. Next, move to chapter 14, which are viewshed and watershed analysis. This chapter focusing on create a viewshed and watershed on mapping and analyze it. This chapter contains 4 main tasks, which are task 1, perform viewshed, task 2, create a new look shapefile for viewshed analysis, task 3, delineate area-wide watersheds, and task 4, derive upstream contributing area at poor points. In task 1, I understand about using perform viewshed analysis. This task 1 covers about viewshed analysis and the effect of the viewpoints, height, offset on the watershed. In task 2 is about create a new look shapefile for viewshed analysis. This task 2 concluding about creates a cumulative viewshed by using 2 viewpoints, one of it which is added through on-screen digitizing. Next one is task 3 about delineate area-wide watersheds. This task 3 contains about the step for the deriving area-wide watersheds from DEM. Lastly, in task 4 is about derive upstream contributing areas at poor points. From using the output from task 3, this task 4 covering about how to derive point based watersheds. This task also taught me by showing how much the importance of snapping points of interest to the stream channel. What I learned from last chapter, which is chapter 17 about discourse path analysis and network analysis. In this chapter, I've been taught about terms such as location allocation, network path, distance, shortest path, analysis, source, raster, traveling, salesman, problem, and turn impedance. This chapter consists 6 tasks. Task 1 and 2, path analysis. I get understand which the least accumulative cost distance in task 1, and the path use the word of network analysis extension. Task 3 runs a shortest path analysis. Task 4 making me build a geodatabase network datasets. Task 5 runs a closest facilities analysis, and task 6 runs an allocation analysis. In task 1, it's about compute the least accumulative cost distance. In this task, I use the inputs from chapter 17 data to create the same outputs. Besides, in task 2 is about compute the path distance. This task is use the data from task 1 to compute the distance. The objective of this task is to find the least cost hiking path from that data in task 1. In task 3, about run shortest path analysis. The objective of task 3 to find the shortest route between 2 cities. In task 4 is about build a geodatabase network dataset. For task 4, I need to examine input data sets first and build a personal geodatabase and the feature dataset. This data will be used in the next task 5. In task 5, it's about find closest facilities. In this task, I will use network dataset from task 4 and point shapefile with 2 fire stations. In task 6, is about find service area. This task allow me to locate the suitable service area on the map documents. The service area considered with the distance and times from that coverage area. In conclusion, what I have learned in all chapter 9, 13, 14, and 17 in ArcGis is about analyzing spatial data. During lab 3, I more understanding spatial data, which is analyzing data and measure geographic relationship. Thank you very much.
Assalamualaikum and hi, my name is AHMAD SHAKIL and I will show you how to do tutorial chapter 9.2. First one, you click file, open from the maps file, you click tutorial 9.2 and then you will see this type of layers in the table of contents. After that, you save as in my size as the file name tutorial 9.2 MSD, click save. After that, you click Windows, search for buffers, and you will click the buffer analysis tool. For the input features, you click car bit centroids. After that, for the output feature class, car bit centroids buffers, and then click save. After that, you see this unit, you type 0.33, and for unit, you click mouse. After that, you see this method, and you click the planner. You click OK, and then you will see this type of polygons. You click the symbolize button, click select hollow. For the outline width, you type 1, and for outline colors, you search for mouse red. Then you click OK. After that, you must repeat the step for the other features. You click window, search, buffers, you click buffer analysis tools, and for the input features, you click retail business. And then output feature class, you must save as retail business buffers in the folder of my exercise in chapter 9. After that, you see this unit again, and you type 0.33 10 unit miles. And then the method is planar. You scroll down. For the list of type, you must click all, and then you click OK. And then you will see this type of maps. After that, you click the symbol polygons of retail business buffers. You select hollow, and then the outline width, you type 1. And for the outline color, you can select blue. Click OK. And then you see this. After that, you search for intersect. You click search, and then you must click the intersect analysis tool. Then you see this table. Okay, for this table, the input features are: first one is car, bit, centroid buffers, and then you click add. The next one is retail business buffers. There are 2 features now, and then you go to output feature class. You type bit business intersect, and then you click save. After that, the join attributes must, you click all, and then you click OK. Just hang on, and then you will see this type of layers. Thank you very much.